video will cover the practice exam for Math 2412 Exam 1. This exam was given in the spring of 2014, 4 years ago. And so, although it says here that you may use a calculator, that's not going to be the case with the exam you're going to take on Friday. So please don't be misled by that. Also, you will not have any scratch paper at all. You will do all the work on the exam. Yes, is that clear? So please make sure you write your name when you take the exam. And then I'm going to solve all those problems without the calculator, so you see how easy it is. So we have problem number 1, convert to if degrees to radians. And so in this case, we need to use the formula pi over 180. And here we will get 135 pi over 180. And of course, the units, degrees, they cancel. And then we have to simplify. I'm going to say that they're both divisible by 5, yes. So then if we divide that by 5, we're going to get 35?
27 is 135, so that's
okay, so 27? Yes? Okay. And then 180 divided by 5?
36.
No. I don't think so, because it can't be bigger. Okay, so let's see. 2, you carry 3. Okay, so that one was okay, but not the 180. What's 180 divided by 5?
No, that is
24.
Okay. So,
Yeah, that was 36.
3, you
It's
carry,
36.
oh my gosh, I have nothing.
It's 36.
36.
Yep.
Yo, let's use a calculator.
It says continue.
Yeah, so good luck with that, guys. 36, so it's 36, okay, and then they're both divisible by 9, correct? 36 and 27? So then that will be 3 pi over 4. And of course, if you have your unit circle, which I will provide to you, but it will be blank, you should know that, right? 135 is 3 pi over 4. Okay, 7 pi over 6, so in this case, we put pi on the bottom. That's 180, so we'll have, in this case, I'm not even going to multiply the numbers yet. So I would just leave them as factors. So 7, and then here 180. Instead of 180, I'm going to say, can you divide 180 by 6?
Yeah, 6 and 30.
6 and 30. Very good. So I'm going to factor the 180 instead. And then on the bottom, I'm going to have 6 and then pi. Oh, and I'm missing pi on top here. So then, in this case, we cancel the 6, pi, and then 7 times 30, that will be 210 degrees. Okay, now, next question, number 2, we are supposed to find a coterminal angle, okay? And a coterminal angle, just so you know, they have the same initial side because by definition, standard position is on the positive x-axis, correct? Yes? Whether the angle is positive or negative, it doesn't matter. And the vertex is at the origin, so all of them have to have that. But for it to be coterminal, they need to have the same terminal side. So it could be an angle that goes like that, or it could be, and that would be like in the positive direction, correct? Or it could be an angle that goes like maybe one turn more, and then it ends there. So that's another example. Now, it could also be a negative angle if you still have your standard position there, and then you go in this direction. So as you see, all of those are coterminal because they have the same terminal angle, right? Yeah, yeah, okay. So for this question, you have to be very careful when you read it. It says, find a positive angle less than 360. That is coterminal, okay? So in this case, we start with a negative angle. So what I would do is add multiples of 360, exactly. And so here, you know, you have different signs because this is positive, correct? So we got to take the difference and then keep the negative sign because that one has bigger absolute value. So then 5 subtract 0, so that would be 5 and then 0, and then what, 4? Okay, and then that's still negative, so we do that again. So negative 4 of 5. I'll try to have like easier numbers.
Thank you.
I'll try, but you're welcome. So then if we add 360 again, so get the difference. So this is a 5, and then what? 4? 45. Very good. And so will that work? Yes, it is a positive angle less than 360, and it is coterminal to that angle. Oh, that's true. So don't do that. So negative 45 plus 360. So we have to do it again. Actually, let's do that the other way. So in this case, 360 minus 45. We will get 5 and then 31. So 315. There we go. Now that one is positive. Okay, now for radians, if you think about it, will this be above 2 pi, is it?
Yes.
Yes, right? Because when we talk about a denominator of 6, 2 pi is equivalent to 12 pi over 6. Very good. And so if we have this and we want to have a positive angle coterminal to this one that is less than 2 pi, so then we're going to subtract 12 pi over 6, because that's like subtracting 2 pi. And if we do that, we will get 7 pi over 6. And that's it for those two problems. Okay, now we have another thing that is called reference angle. Let me see if I have a question like that here. Right here. Let's go to number 8. So reference angle, guys, is not the same as coterminal, please. Don't tell me that you didn't know. They're different things. The definition for reference angle is that it is positive and it is acute, and one of the sides is the x-axis. Whether it's positive or the negative, it doesn't matter. So for this one, we need to find the reference angle. So you have an angle that, of course, is more than 2 pi, correct? Yes? So let's see how big it is. If we had the fraction 35 over 6 and we convert it into a mixed fraction, it could be something like 5, right? And then what else? 5 over 6. Very good. So if we have, if I put pi here, then here I'm going to have 5 pi, right? And then plus 5 pi over 6. And so I'm gonna try to draw it. So remember 5 pi, that will be like 4 pi, so that's like 2 complete turns. And then an extra pi, so like a half turn, okay? So I'm gonna draw it. So I'm gonna go start in the positive x-axis here, and then I will go 1 full turn, that's 2 pi, another full turn, that's 4 pi, and then only an extra half turn, that's 5 pi, and then I still need to go 5 pi over 6. So it's like almost the complete half of, not half, half a circle, yes, or an extra pi. But how far away am I going to be from getting to the 2 pi?
1 extra 6.
1 extra 6, very good. I like how you said that. So that reference angle in question, this one here, is that extra pi over 6. What we were missing to get to the full, what would have been that? 6 pi, right? Because 6 pi is equivalent, and with a denominator of 6, is equivalent to 36 pi over 6. So if you don't want to draw it, then you could have done, I'm just better if I draw it or convert it to a mixed fraction. You could also do something like, to the 35 pi over 6, you will just keep subtracting multiples of 2 pi. let me see, if we subtract 12 pi over 6, let's just do like 24 pi over 6. So what do you guys get right there? 35 minus 24? 11 pi over 6, right? And so maybe that one can help you out, visualize the situation. How far is it away from the 12 pi over 6? 1 pi over 6. So that's another way to find it. Okay, just remember that the reference angle is always positive, okay? And actually, that's just one part of the question, to find the reference angle. The other part is to give me all the trigonometric functions. So because your theta prime, we agree it was pi over 6, correct? But do you guys remember what was the terminal side of our angle in question, the 35 pi over 6? Right here. So it's quadrant 4. So in quadrant 4, the trigonometric functions, the signs for them, and I'm going to go in this order: sine, cosine, tangent, okay? So for sine, that's the y related to the y value. So y's are positive here and here. Y's are negative here and here. Then let's talk about cosine related to x. The x's are positive in quadrants 1 and 4. They're negative in quadrants 2 and 3. What happens with tangent? Tangent is, by the quotient identity, it is the ratio between the sine and the cosine. So if you divide two positives, you get positive. If you divide two negatives, you get positive. So tangent is positive in quadrants 1 and 3. And it is negative in quadrants 2 and 4. So please do not forget that, okay? So once we write all the, and by the way, pi over 6 is equivalent to 30 degrees, right? So then we're going to say for this angle, the 35 pi over 6, we're going to find all 6 trigonometric functions. That's what it says here, exact value. Okay, and so do you guys remember what is the sine of pi over 6 or the sine of 30? My favorite, 1/2. Now, if we're talking about this quadrant, quadrant 4, should that be positive or negative?
Negative?
Negative, right? Because we're talking about 35 pi over 6. We're just using this one to help us out, but we still need to keep track of the signs, okay? So we're going to be working in quadrant 4. Okay, so that's negative. Then the cosine is going to be positive or negative? Look at the board. Positive. So positive square root of 3 over 2. And I know that because I know that the cosine of pi over 6 is that. And for tangent, if you don't remember, you could divide one over the other. Right here, you will have negative square root of 3. Wait a minute. I'm sorry, I'm completely wrong. So negative 2 over 2 square root of 3, right? The 2's cancel, so you end up having negative 1 over the square root of 3. Should that be negative? Yes, yes, that should be negative. Now, if you have time to rationalize, do it. If you run out of time to rationalize, I'm fine with that, as long as they're equivalent. So if you rationalize, it would be square root of 3, square root of 3, and that would be negative square root of 3 over 3. Very good. Now, if you know those 3, you obviously know the other 3, correct? Cosecant, it will be the reciprocal of that, so negative 2. Secant, it will be the reciprocal of that, so 2 over square root of 3. If you don't have time to rationalize because you're running out of time, just leave it like that. It's fine. If you rationalize, it will turn into that. So 2 square root of 3 over 3. And then finally, for cotangent, what should I use? The reciprocal of the version before rationalizing, right? So that will just be simply negative square root of 3 over 1, or just the negative square root of 3. Now, what I'm like, it really hurts my heart when I have to do this. But sometimes you have the correct number and you have the incorrect sign, and I will count it wrong. There's no partial credit for that because you are actually telling me the complete opposite of your answer. Your answer is not just wrong; it's the complete opposite. Are we clear on that? So you need to really check what quadrant you're working with. Okay. All right. Let's go back to this one here. So for the arc length, find the length of the arc of a circle with a radius of 8 inches, intersected by a 45-degree center angle. So let's see what that will look like. So we're talking about a circle, and 45 center angle means that the vertex is at the center of the circle. And so we want to find the length of this little piece right here of the arc. And we know that the radius is actually, we cannot say it's also 45 because the radius is 8 inches. Okay, so it's not going to be the same. Remember about the carousel, the horses at the end, they travel a longer distance. So the length of that arc would be bigger. So we'll use the formula for arc length. S is r theta. Could you have the formula sheet during the exam? No. Only during the final, which is cumulative at the end of the semester. So one thing you must remember, okay? You must convert to radians. That's another question that it really hurts my heart if I have to count it wrong, because I know that you know what to do, but you just forgot to convert to radians. So please do it. So we have the center angle at 45. So then theta is 45 degrees, and what is that in radians? Very good, pi over 4. And so then you can apply the formula. And so that will be, the arc length will be the radius, which is 8, times pi over 4. And so that will be 8 pi over 4, which is equivalent to 2 pi. What happened? Yes, and that's it. 2 pi. Okay. Now the next problem, I'm gonna leave it at the end because that one is on the other video. So I'm gonna, if I run out of time, then you have to watch that. Let's look at this one here. This is a very common one that people get wrong. So let's imagine what they're talking about. So they're giving us a point, and the point is on the unit circle. So that point is on the unit circle. And we're going to call that angle beta, and it is in standard position. And the terminal side is intersected by that point. So that's why that point, the coordinates of the point are important. So if I plot the point, this will be the x coordinate and this will be the y coordinate, right? So I'm going to plot the point. So I'm going to say it's like, okay, so this is -1, so negative 17 over, negative 15 over 17 is like almost -1, but not quite. So I'm just going to assume it's here. And then for my y value, that would be like maybe like a little bit over half. So maybe here. So then my point is here. That's my point. Okay, so then the angle, what the problem says is that the angle is in standard position, and then it goes in this direction, and the terminal side is intersected by that point, like that. We're talking about that type of angle, okay? And so, since we have the coordinates of the point, we know, and we're talking about the unit circle, so we could do the following. Just simply take the sine as the y coordinate, which is 8/17. Then we would take the cosine. Did I do this wrong? No, it's fine. The cosine as 15/17. Then what is the tangent going to be?
Should I do the 15/8?
The other way. -8/15. So the one that you told me that would be the cotangent. Now let me show you why it's -8/15. So we take the sine over the cosine.
It was y over x. Yes.
Correct.
Okay, so that's
So then if you do that, the 17s will end up canceling. You end up with 8/-15. The negative could be with the 8 or the 15. But if you do not have that negative, I'm going to have to count it wrong. Is that clear? And how many points is this worth? 6. Okay? So please consider that. Okay, so for cotangent, reciprocal of that, I think I'm going to just skip this because well, let's just write them down. Okay, so Angel, what is the cosine? I'm sorry, it should be the cosecant. The reciprocal sign, Angel? Very good. Isaac, right now? Secant?
17/15.
Very good. And if you leave the negative with the 15, I'm perfectly fine with that. I don't care. Cotangent, Isaac?
15/8.
Very good. And so that's it. Now with the triangle, guys, this one, of course, you have to use some Pythagorean theorem, okay? And if you have the same triangles, like, don't be surprised, but I might change the numbers, okay? So don't just rush. Make sure you read your own triangle. So in this case, if we use Pythagorean theorem to find b, just keep in mind that b squared is c squared minus a squared. And so b will be the square root of c squared minus a squared. Very common mistake, students will put a plus here. That's wrong. Okay, and then make sure that you get a positive number out of here because you're talking about a triangle with positive dimensions. Okay? So for this one, you also have to get all 6 trigonometric functions, but they will all be positive. Keep that in mind, okay? So if you do something weird, because I know you guys do that when you're using the square root. So you have 3 squared and then minus 1 squared, so that will be the square root of 9 minus 1, so that's the square root of 8. And that is the square root of 4 times 2, and that is the square root of, that is 2 times the square root of 2. Now, if you don't feel comfortable like getting to this, just leave it here. It's fine with me. I will grade it. If you get like a weird number and you're not sure. I would rather you leave it there rather than you get like something wrong over here, because then all of your answers will be wrong. Okay, so then for sine, we're talking about this angle, so we know this is 2 square root of 2. So for sine of that angle will be the opposite over the hypotenuse. For the cosine, it's going to be the adjacent over the hypotenuse. And then for the tangent, we're going to have the opposite over the, adjacent, right? If you just want to leave it there because you don't want to rationalize, that's fine with me. If you rationalize, it will be the following. Because when I grade the exams, I have like both answers with me, so it's fine. And that's actually what AP Calculus is all about. Like, you don't even have to simplify. So square root of 2 over 2 times 2, right? Because from this 2 square roots, we cancel.
Be over 3. Or isn't it just?
No, it will be 1 for opposite and 2 square root of 2 for adjacent.
I'm looking at the cosine.
The cosine is adjacent to square root of 2 over hypotenuse, which is 1. So that one is just kind of cheap. Oh, yeah, okay. I believe you. That's it. Alright, sorry. So square root of 2 over 4. So don't do that on the test. Take your time. It's probably going to be shorter. I don't know. I really don't know. I really like to make my attempts the night before. I really do. So don't ask me what's going to be on the test, how many questions. I don't know. And you shouldn't even care. You shouldn't worry about that. You should worry about learning. Okay, now the next one. This one is different than the one that I give you a point that is in the unit circle. Okay? So for problem number 7, you have to read the question. And you have to use the information given. Okay? So first of all, we're talking about a positive tangent and a negative cosine, right? Less than 0. So let's see. Cosine is negative in quadrants 2 and 3. And the tangent is positive in which one? Out of 2 and 3?
3.
3. So that's where we are going to be working. So when you are given the tangent of an angle, you're actually being given the opposite side and the adjacent side. So here we're saying, or in terms of y and x, you're being given y over x, correct? Yes? So then the y coordinate happens to be negative 5. 1, 2, 3, 4, 5, 6. Oh, oops. So negative 5. And the x coordinate happens to be 12. I'm just going to say this is 12, okay? It's not drawn to scale. Negative 12. So then that point, I want you to do this. Before you draw a triangle, because I've noticed how you do it, sometimes students tend to draw, instead of a triangle like that, they tend to draw like a little flag. Let me see how you guys do this. Like that. Okay? So don't do that. Don't do that. Think about the bow tie. It has to look like a bow tie.
Oh, wow.
Do you guys see that circle right there?
Yeah.
It's just like bow ties or butterflies. Think about something like that. So you connect the origin to your point, and then instead of connecting it to the y-axis, because that would look like a flag, right? You connect it to the x-axis, like that. Then you have your triangle to work with. So your opposite side, your y, we already agree is negative 5. And your adjacent side to this triangle, or to this angle, I should say, which is called theta, by the way, is going to be negative 12. Now, the hypotenuse of this triangle is going to be positive, right? Yes, so let's see, is it 13? Let's make sure. So C is the square root of negative 5 squared plus negative 12 squared. Oh yes, this is where you might make a mistake. Please do not forget that when you square a negative quantity, it's always going to be positive. So please don't be giving me fake answers here, okay? I'm so tired of fake news and fake facts. Alternative facts. There we go. Okay, so this will be positive 25. Don't you ever say it's negative 25. And then we have a big plus here because we're finding hypotenuse, not a side of a triangle. So then the square of negative 12 is also positive because this negative times a negative. And that will be 144. The square root of that is if we combine them, is 169. And the square root of that is 13. I'm going to give you a square root that will be easy for you to find. Like the square root of 16 or 25. So please don't stress about that with the calculator. And then after that, you have to find sine, and the other, and this one is 5 points. Why is it not 6? Thank you. I already gave you one. Okay? So don't even bother writing tangent. It's already there. So this is the most common mistake I see on exams. Okay? Students look at it and they're like, oh, okay, so tangent is sine over cosine, so then the sine is 5 and the cosine is 12. I see it every year. Isn't it like a good reasoning? Sine is 5, cosine is 12.
They say
Well,
X and Y.
Right, yeah, so it kind of matches that, but I never said we're in the unit circle. That's why you cannot do that. And then also, it's completely nonsense because what is the range for sine?
Over hypotenuse.
No, I'm sorry, the range. So the values that you will get, the outputs, from -1 to +1. So, nonsense. Okay, so don't do that because it hurts my heart, but I will count it wrong. So what do you have to do? You have to make sure that you find that number right there because the sine is actually going to be -5 over 13. It has to be a fraction in between that interval -1, 1. The cosine is going to be adjacent -12 over hypotenuse 13. So your answers have to be like fractions, like they did here as well, and they have to be smaller than 1. All right? Between -1 and 1. So let me see what else. We're almost out of time. Let's do this one here. So for example, let's see, find the exact value of each expression. So we have the cosine inverse is defined in quadrants 1 and 2. And it goes from 0 to pi. Right? Yes. So let's see. What could be the cosine positive of which angle, of which positive angle is the cosine square root of 2 over 2? You guys know it. 45. Very good. Let's say it in radians. Pi over 4. So I solved this part inside. Now what is the sine of pi over 4? Easy, right? Square root of 2 over 2. Okay. Okay, next one. Could we cancel here like that? No, because this angle, well, actually, yes. Wait a second. You guys are confusing. Isn't it 2 pi over 3 like right here?
Yeah.
So yes, if it was sine, no. Because sine inverse, if it was sine inverse, we couldn't. Because sine inverse is defined here. So then 2 pi over 3 will be like over here. Okay? But for cosine, yes. So for cosine, as long as that angle is in this interval right here. For cosine inverse. And so we know that 2 pi over 3 is right here. Right? So we do cancel, and the answer is just 2 pi over 3. Could we cancel the next one?
No.
Actually, oh, it's cosecant. I thought it was cosine. I'm sorry. Oh, so make sure you guys check that. So then we're going to have to work with the cosine. And so cosine here, negative, we're talking about quadrant 2, whereas the cosine negative square root of 3 over 2. And so if you have your unit circle with you, you're going to figure out that it's the angle that has the same reference angle as pi over 6. So it's going to be an angle that goes from here to here. What angle is that? Very nice. 5 pi over 6. How do we know that? Because the reference angle is pi over 6, and the cosine of pi over 6 is the square root of 3 over 2. Now here the cosine is negative, so that's why we know it's 5 pi over 6 and not pi over 6. Yes? Quadrant 2, because the cosine is negative. All right, so then we answer what's in here, and we still have this cosecant part, and we put here 5 pi over 6. Okay, and so for cosecant, you might feel like, oh, well, I don't know what that is. Well, but you know what sine of 5 pi over 6 is. You have to know, because that's my favorite. This is sine of 30. 1/2. Why am I saying that? Because I'm using the reference angle pi over 6. Now, is the sign positive or negative in quadrant 2?
Negative.
No.
Positive.
Sign. Positive. The y. So then the cosecant, is it going to be positive or negative?
Negative.
And isn't it true that cosecant is the reciprocal of sine? So what's the reciprocal of 1/2? 2. Oh, that's too easy. Okay, so this concludes our review. I will try to go over the ones I didn't get done in this one, and then I'll record another video, just so you guys can get them all. Okay? All right.